Hi everyone. In this video we're going to go over what we did in class today on simultaneous equations using our third method, which is our graphical method. So far we've solved simultaneous equations through elimination or through substitution. And of the three methods, this one we're about to look at is actually, I think, the most intuitive. But I've left it till last because I wanted everyone to first get a good understanding of the maths, the algebra behind solving simultaneous equations. And then once you had a good grasp of that, now we can move on to the graphical approach, which is, like I said, somewhat more intuitive. So let's start by having a look at two equations that we can solve simultaneously. So the first one is y equals half x minus 2. That's equation 1. And let's say equation 2 is x plus 2y equals 8. Now the way we're going to solve this is by graphing both of these equations. The first equation is rather easy to do that too because it's already in the format y equals mx plus c. So I can graph that straight away. If I take out my graph paper, I'm going to give it a y-intercept of -2. And it needs a gradient of a half. So that means I need to go across 2 to go up 1. And if we join those up, this here is the line for equation 1. Equation 2, we can also plot that because it is a linear equation. However, it's not in the format y equals mx plus c. So there's two ways we could go about plotting it. We could rearrange it to put it into the format y equals mx plus c. But I actually don't want to do that. Instead, we're going to do what we did in class today, which is the easier way of doing it. We're going to pick 2 points on the graph, plot those, and then use just those 2 points to draw my line. And the two easiest points for me to find are when x equals 0 and when y equals 0. So when x equals 0, I get that 2y equals 8, which means that y equals 4. So that would be the point 0, 4 on the graph. And when y equals 0, I simply get that x equals 8. So when y equals 0, x equals 8, which gives me the point 8, 0. So now I can plot both of those points on the graph. So when x is 0, y is 4, and when y is 0, x is 8. And I can join up those two points to create my linear graph. And this here would be the line for equation 2. And now solving these equations simultaneously becomes very simple. It is simply the solution is the point of intersection between the two lines. So the coordinate of that point of intersection is the point 6, 1, which means that my solution to these equations is that x equals 6 and y equals 1. And if you wanted to, of course, you could substitute 6 and 1 back into both of these equations to double check that it works. Okay, we're now, before we wrap this up, we're going to look at a worded problem. So let's have a look at this one here. A farmer is tracking the growth of 2 small plants. When he starts tracking, plant A is 2 centimeters tall and is growing at a rate of 3 centimeters per day. Plant B is 12 centimeters tall and growing 1 centimeter every day. By graphing this information, determine how long it will take for the two plants to be the same height. Okay, so we've got plants A and B. I'm going to introduce the variable x, where x is the number of days that since the farmer started tracking, the height of these two plants. Whoops. Since the farmer started tracking the height of these two plants. So the height of plant A will therefore be, well, it's got a constant, it starts with a its constant value of 2 centimeters, and it's growing at a rate of 3 centimeters per day. So that means that the height of plant A is 3x plus 2. And similarly, the height of plant B, well, plant B has a constant, its constant that it starts with, its initial height, is 12 centimeters, and it grows at 1 centimeter every day. So the constant is 12, and it'll just be b equals x plus 12. And I want to know how long it will take for these two plants to be the same height. I'm going to do that because the question told me that's how it wants me to do it, by graphing those two things. So if I bring my graph here, we've got, for A, I've got a y-intercept of 3, and a gradient of, sorry, I've got a y-intercept of 2, and a gradient of 3, so that means for every 1 I go across, I need to go up 3. So my line for plant A is going to look something like this. And of course, if this was, a test, there would be a more precise graph paper to use. That would be the line for plant A. And plant B has a y-intercept all the way up at 12, and it's got a gradient of 1, so that means for every 1 it goes across, it only goes up 1. So my graph for B is going to look something like this. Now the point of intersection there, again we can't see it super precisely with the way that I've drawn this graph, but the point of intersection there would be the point 6, 20. That means if we jump back to the question to answer the question, how long will it take for the two plants to be the same height? So these two lines tracking the height of each plant, where this line is plant A and this line is plant B, it becomes obvious that the point of intersection is what we're looking for, and that point of intersection happens at the x value of 6, so it will take 6 days for those two lines to intersect, or 6 days for the two plants to reach the same height. So just to recap, what I want you to take away from this video is solving simultaneous equations graphically. Firstly, if we have two equations like this, where if one of them is not in the form y equals mx plus c, instead of rearranging it, we're going to just pick 2 points when x is 0 and when y is 0, and we can solve that graphically like we did there. And secondly, when we have these worded questions, we can often get 2 linear equations which we can graph to solve them simultaneously like we did there. The most important thing to remember is that the point of intersection on the graph is the solution to the simultaneous equations